Okay, so there's three types of bonding, right? You have covalent bonding, where they share an electron. You have ionic bonding, where one atom transfers or gives an electron to another atom. And you have metallic bonding. This is where there are free electrons everywhere for anybody to take. So all you have to know is ionic is when an atom transfers an electron to another atom. Covalent is when an atom or two atoms share an electron. And metallic bonding is when there's a sea of free electrons for anybody to take. So when I see the word transfer, know that's ionic bonding. Usually this happens between metal and non-metals. Covalent happens between non-metals. And metallic is obvious. It happens between metal atoms. 23, when you see covalent bonds, look for the word share. So a pair of electrons are shared between two non-metal atoms. Number 24, metallic bonding occurs due to the presence of a sea of free electrons. So if you look at this picture, these over here are a sea of free electrons. Number 25, if for example I have weak intermolecular forces, if the strength of the intermolecular forces is weak, that means the boiling point is less. If I have strong intermolecular forces, say for example, I like to think of it as these two, they hold on to each other very strong. You need a lot of heat to break these forces. But if they have a very weak intermolecular force, you only need a little amount of heat to break it. Blank are materials that allow heat. When you see allow heat and electricity to move easily through them, when you see the word allow, know those are conductors. Number 27, if it resists or stops or prevents the flow of heat or thermal energy, these are called insulators. So example of conductors that allow heat to pass through are metals. And something that resists the flow of heat, maybe rubber, wood, etc. Number 28, steel is a mixture of iron and carbon, which is considered to be when you mix a metal with another metal, or a metal with a non-metal, it's called an alloy. So conductors, what lets heat and electricity pass through them? Copper and gold, because these are metals. A device that measures temperature, it's called a thermometer. A temperature scale that is used mostly in the US. So in the US, they use Fahrenheit. Another temperature scale that scientists use, because it begins at the absolute coldest anything can get. When you see scientists or you see absolute zero, they like to use Kelvin. That's the official temperature scale for scientists. And the last one, the most widely used, they use this everywhere in the world besides US and some other countries. We use this in Qatar, Celsius. And you know Celsius, water boils at 100 degrees, and it melts, or the freezing point and the melting point is 0 degrees. So if I want to go from Kelvin to Celsius, they will give you this on the exam, the formula, but I need to minus or subtract 273. So I have to borrow from the 4, that's 3. This is going to be 15. I have to borrow from the 15, that'll become 10. This will become 14. So 10 minus 3 is 7. 14 minus 7 is 7. 3 minus 2 is 1. Convert 150 degrees Fahrenheit to Celsius. So they will give you the formula for this. So this is the formula. To make it easier, because you don't have a lot of time on the exam, I'm going to change this to 5 over 10. Right? And 5 over 10 is the same thing as half or nus. So C Celsius equals half times F 150 minus 32. So 150 minus 32 is 117, and a half of 117. Sorry, this is 118. So half of 118 is 59 degrees. And this is an estimate. It's not the exact answer. So the closest to 59 degrees is 65 degrees Celsius. It's not Fahrenheit because they want Celsius. Number 36, pressure is measured in what? Pascals or PA. Pressure can be measured in pascals or newtons per square meter. If I use my formula, P equals force divided by area. Force is in newtons, area is in meters squared, or square meters. So it's the same thing. N divided by n squared is the same thing as PA. So it's true. So the pressure resulting from a force of 50 newtons exerted over an area of 5 square meters. So 50 newtons divided by 5 is going to give me 5. Is going to get to me 10 newtons per square meter, or 10 pascals. Number 39, which has the greatest pressure? So over here, over here, over here, over here. So pressure equals force divided by area. So the smaller my area is, the more force, or the more pressure there is. So I'm gonna look at which object has the least amount of area. It'll be D. Which of the statement is true? The bottom of the high heel exerts more pressure than the sneaker as a result of the decrease in surface area. So this is true. Because there is less surface area over here, less surface area or less area means more pressure. 41, we already said pascals is pressure. 42, what happens to air pressure as you move upward into the atmosphere? So if I go to the top of a mountain, the pressure decreases. And if I were to go below sea level, the lower I go, the more increase there is in pressure. So what happens to air pressure as you move upwards? If you go upwards into the atmosphere, the pressure decreases. A device that is used to measure atmospheric pressure is a barometer. 44. When the temperature of matter increases, the particles, so remember these little particles of matter, if I increase the temperature, right, the particles are going to move faster and farther apart. So they speed up and move farther apart. How do gas molecules move? Number 45. Randomly. I don't know why this is there. Randomly. Or Brownian motion tells us that it's random. Okay, so number 46. Gases, true or false, gases can be compressed. So can they be squeezed? So if I look in this picture over here, they can, see? If I apply pressure here, the liquid, water, can compress a little bit, but the gases are easy to compress. So they can be compressed, so it's true. Gases and fluids or water or liquids, whatever you want to say. 47, which container will have a lower pressure? So if I decrease my volume or my hajm, right, I made my volume smaller, my pressure will increase because these particles are moving, keep hitting the wall, keep hitting each other. So the lower pressure is this over here because there's a high volume, which means less pressure. Number 48, which would increase the pressure of a system? Okay, number 48, which of the following increases the pressure of a system? So, say for example, if I have this box over here, we zoomed into an object and we have these particles over here. One, if I increase the temperature, if I put more heat, I know these are gonna, this is gonna increase the pressure because these particles are gonna move faster and farther away from each other. So increasing the temperature does increase the pressure of the system, right? No, D, if I pump in more gas, say for example, if I were to put in more of these particles, they're going to hit each other, they're going to hit the container more, so that means the pressure is going to increase. And the last one, decrease the volume. So instead of making the volume this big, I made it a little bit smaller, right? And I have the same amount of particles. They're going to hit the container more and hit each other more, so there's more pressure. So all of these increase the pressure of the system. Number 49, I have to move quicker. A gas occupies 4.98 liters, so this is volume 1, at 2.6 atmospheres of pressure. This is P1. What volume, V2, does it occupy at 1.8 atmospheres, P2? So you will have this formula on the exam. P1 V1 equals P2 V2. So 4.98. Actually, you know what? 4.98 times 2.6 equals P2 times, no, my P2 is 1.8. 1.8 times V2. So if I don't have time in the exam, I'm just gonna I'll estimate or approximate 5 times. Yeah. So I'll round the 2.6 to 3, the 1.8 to 2 times V2. 5 times 3 is 15 equals 2 V2. I'm going to divide by 2 to get V2 by itself. 15 divided by 2 is 7.5. So my answer should be close to 7.5. 7.2 liters. 50. So they give me the formula V1 over T1 equals V2 over T2. 500 liters is my V1. My T1 is 200K. My T2 is 400K. What is the new volume, V2? So 500 over 200 equals V2 over 400. So I'm going to do the maqas or the scissors. 500 times 400 equals 200 times V2. So 500 times 400, 5 times 4 is 20. I'm going to add the 4 zeros. 1, 2, 3, 4. Equals 200 times V2. I'm going to divide by 200 to get V2 by itself. Cancel out the zeros, cancel out the zeros. 2000 divided by 2 is 1000. So, a sample of oxygen at 28 degrees Celsius. This is my T1. 340 kilopascals is my P1. My temperature 2 I don't know. My pressure 2 is 150 kilopascals. Don't forget, anytime you have temperature, it has to be in Kelvin. Here it's in Celsius. So how do I change it from Celsius to Kelvin? I add 273. That gives me 301 Kelvin. So I'm going to do is I'm going to go to my formula now. P1 equals 340 over 301 is my temperature. My P2 is 150. My temperature 2, I don't know. So 340 times T2 equals 301 times 150. I could just do 300 times 150. But actually for now I'll just use the calculator. You guys are not going to have a calculator in your exam, but I'll do 150 times 301 to give you the exact answer. 45,150. I divide by 340, divide by 340. My T2 is 132.8 Kelvin.